Hey ChemStars, this is Mrs. Vanderlei bringing you the second edition of the ChemStar video. Today we're actually going to do 1.2.2, which deals with the properties of matter. So why am I on the front page again? Well, I'm looking at the definition of chemistry. It says again, chemistry is a study of the composition. That's what we learned in the last one. When we talked about atoms and elements and compounds, that's the composition. The structure. We kind of dabbled it a little bit in the structure, but not really a lot. We're going to do that much more in detail probably around Christmas time. But section 1.2.2 talks about the properties of matter. So we are going to discuss this. Today's video is all about the properties of matter. All right. Future ones will talk about the process that they undergo and the energy changes. But today we're talking about the properties. So let's go to page 4. So here we are. The objective for this video is you're going to describe the properties of matter. Well, what specific properties? Well, we're going to talk about intensive and extensive properties, and then the phases, the solid, the liquid, the gas. So that's what this whole section right here is all about. So to talk about the first part, the intensive versus extensive, I want to have a visual for you. So I would like to have the Hershey's chocolate bar. So here is if you look at it, a giant bar. Do you see that here? This is going to be a giant bar. And I want to compare it to little miniatures. All right. So just look at this one right here, the little miniature guy. And so what the question here for extensive property is, it's a property depends on the amount in a sample. All right. And so my question for you is, okay, how are these two chocolate bars different? All right, obviously one's giant and one's a miniature. So how are they different? Well, they're different only due to the size. They're only different due to the amount that's there. So what kind of things can I describe this giant bar? Here, I'll scroll it down again. And the miniature bar that depends on size. Well, here's some for you. I think maybe the first thing might come with weight, or we use mass in science. All right, we can read this label here. All right, it's like 7 ounces, and I have no clue what this one is. But they're gonna have different weights, but we'll talk about mass more than anything. How about this? I mean, if I were to actually measure the length and the width, all right, wouldn't the area, the surface area, be different? Yeah. I go one further and take length times width times height. What's that? That is volume, all right? And here's one that maybe you aren't thinking about, but if I were on a diet, which one would I eat? Would I eat the giant one or the little one? Well, if I was on a diet, you'd probably say the little one. If I weren't on a diet and I could have whichever one I want, you'd probably say the big one. So if you're on a diet, what are you counting? You're counting the calories. All right, and what is a calorie? All right, it's a unit of energy that in a sense is required to burn off what I just ate. So how much exercise do I need to burn off the giant one versus to burn off the little one? All right, that's what a calorie is. So the amount of calories depends on how much. Okay, well, opposite of that is an intensive property. All right, I'll scroll these guys down again. Oops, let me go get the other one. Here it is. All right, so here is the this guy again. So intensive property is a property that does not depend on the amount of matter in the sample. So in other words, what do all these guys, the big one and the little one, well, what do they have in common? Or in other words, how are they the same? Okay. Well, the first obvious, I hope it's obvious, is they taste the same, right? Wouldn't you agree? One bite versus a huge bite, they're going to have to taste the same, all right? What else might you notice? Well, they look the same, all right? They have the same texture. What if I were to set them out on the counter on a hot day? What might happen to my chocolate? Well, they're both going to melt. They have the same exact melting point. Something else that you probably don't have any reason to worry about, but density. I'm sure you've talked about density some point in your life before. The densities are the same, all right? So if I were to stick a big piece of chocolate and a little piece of chocolate in some water, all right, they're both going to sink. They have the same density. And so why is this important? Why do all these intensive properties, why do we care? Well, because these are the properties, maybe I'll write this down. These are the properties that you can look up. All right, if you have an unknown sample of something, all right, you can determine its density and then look up, well, what has the same density that you do know. You look all these things up. All right, you don't say that every Hershey bar has the same mass and you can look it up. No, that's not correct. But every Hershey bar is going to have the same density. Every Hershey bar is going to have the same melting point. You're not supposed to eat things in lab, but they're going to have the same taste. Okay, so that's really important as far as why do we care. Okay, so let's talk about some other physical properties. Let's scroll down. Every sample of a given substance has identical intensive properties. That's what I was just talking about, because every sample has the what? The same composition. Well, what's a composition? That's what we learned in the last section. So they have the same elements. Those elements are arranged in the same exact way. So because they're arranged in the same exact way, they're going to have the same intensive properties, okay? So a physical property is a quality or a condition of a substance that can be observed without changing the substance's composition. All right, so for example, well, before we talk about that, it's like, what can you do to that Hershey's bar that it will still remain the same yummy chocolate? All right, so what can you think of? What can I do to that giant Hershey bar that is going to retain that same taste, that same color, that same texture? All right, what's going to happen? Well, you can cut it into smaller pieces. It's going to still taste the same. You can melt it. It's still going to taste the same, but maybe now you want to put it over some ice cream because you've melted it. All right. Those are going to be physical properties. It's still the same stuff. All right. But you just change, in a sense, its location. Okay. So those would be physical properties. There's others out there, but I think you get the idea. So states of matter, well, it kind of talks about this idea of melting, all right? When you melt something, what are you going to do? You're going to go from a solid to a liquid. So you are changing its states of matter, okay? So a solid, we say, has a definite shape and a definite volume, all right? So like that solid Hershey's bar, it is in a rectangular position. I can do length times width times height. It has a very definite volume. Um, Now, liquids will have the same volume. It has a definite volume. You can use a graduated cylinder to measure it, or you can use, say, maybe like a beaker or something. But your graduated cylinders, some are fat, some are skinny. Um, it takes the shape of that cylinder. It doesn't have the same volume, but it takes the shape of that cylinder. So there's no definite shape. If you're to put a chunk of Hershey bar in a graduated cylinder, it retains that same shape. If you put the liquid Hershey bar, that you melted, in a graduated cylinder, it's going to take the shape of that graduated cylinder. Now, what about gases? They have no definite shape or definite volume. They take the shape and the volume of the container. So if you make a bigger container, they just expand to fill it up. If you shrink the volume, then they're going to be compressed and still fill up the same volume. Now, what's the difference between a gas and a vapor? A vapor describes the gaseous state of a substance that is generally a liquid or a solid at room temperature, like water is. All right. So if you are to evaporate water, water is typically a liquid at room temperature, but if you were to evaporate it, we call it a vapor. Okay, so water is a vapor at room temperature. If it's vaporizing, okay, it's going to go away. If you have a puddle of water on your desk or something, it will eventually go away. But what about like oxygen? Well, it is a gas at room temperature, so we wouldn't call it oxygen vapor, we just call it oxygen gas. So let's take a look at these particle diagrams. If I were to look at my solid Hershey bar, all right, and I put it, let's say, in a petri dish or something that's circular here, right? What's it going to look like? Well, it retains its shape, doesn't it? Okay, it retains the shape. It doesn't fill up the petri dish or the glass, if you will, okay? But what if I were to melt my chocolate, all right? Well, it takes up the shape of the glass, all right? Notice what I did though. So it looks like there are 11 circles here. Well, there's still 11 circles here. So in a sense, the mass did not change, All right, by melting it, all right, it just has a different volume. It just takes up a little bit more space, all right? Notice that the particles are further away from one another than they are in the solid form, all right? And that is true of most things, but water is kind of a unique property as far as that goes. So um, that's why like your ice expands when you freeze it than what you have with the water. So water is an exception to what I'm drawing here. So that's why I'm using Hershey's, okay, Hershey's chocolate. Now I have no clue why you'd ever want to do this, but what if you want to vaporize your Hershey's chocolate? All right, don't know why, but you're gonna do that. So this is what I have here. All right, so you might have one gaseous or vapor of chocolate in your little glass here, and all the other ones are gone. All right, they've all spread out probably into the room someplace. So I don't have 11 molecules of gas chocolate there, do I? It is totally spread out. They don't take the shape of the container the glass it's in. It's probably now in your room. Okay. So anyway, those are your three states of matter. Hopefully this looks familiar. All right, you probably haven't thought about chocolate that way though, have you? So anyway, this is the end of section 1.2.2. We talked about the different properties of matter, and I hope you enjoyed the spin on the chocolate there. So that's it. So don't wait to be great. See you next time. Bye-bye.